Today we will see the set operations. Yesterday what we saw? We defined what's a set, then we saw the types of set, representation of set, and then also the types of set. Actually, yesterday I should have mentioned one thing. Okay, it's a simple. You remember the number of elements in the set. What is the symbol we got? N of A, right? This is also called as a cardinality. Okay? This is also called a cardinality of set A. Okay? When they write cardinality, it means number of elements in the set. Okay? Can you tell me what is the cardinality of an empty set? 0. Correct. Yeah. Okay, fine. So we are going to see about the set operations today. Okay? And first set operation, what is called the complement of a set. Okay, the complement of a set. What is that? Complement of a set. That is, okay, so you are given a set A. Okay, so when you define a set, you also have to define a universal set. Am I right? See, for example, if you want to write, if you want to define a set, A is a set of even numbers, even natural numbers. Then what do you write? A is equal to x such that x is an element of natural numbers and x is even, right? Even. Okay, here what should be the universal set? Whole number, natural numbers also. Element of natural numbers. Okay. So whenever you are defining a set, there has to be an universal set on which you are going to, based on that. Means whatever the set you are going to construct, universal, all, okay, that's interesting. All sets will be a subset of universal set. Okay, proper subset of universal set. So that's a universal set, all possible sets. Okay, so and now complement of set, a set A is that all the elements of the universal set which are not the element of A. You got it? So for example, it's very simple. Suppose if a universal set is, so what the complement set is denoted by, okay, yeah, they are not set of all elements in U which are not in A. So for example, suppose A, if I write A is equal to, say 1, 2, 3, 4, 5, and my universal set is x such that x is an element of natural number and x is less than 10. So now can you tell me what will be A prime?
6, 7, 8, 9.
Correct. 6, 7, 8, 9. Right? Okay. So now, how do you represent this in the Venn diagram? Venn diagram is easy. Venn diagram will be interesting. So what happens? So first Venn diagram, you are going to have to construct a universal set. Okay, this is a universal set. Right? And now A is a set in the universal set. A should be obviously a subset. We all set is a subset of universal set. So let me represent the A as a circle. Okay. Now can you tell me what will be A prime?
The
Rest of the area. So this is your complement of A. This is your A prime. Okay? Clear? So this is what you call as your complement of set A. Okay? So see here I have not given the numbers. Yesterday you were asking, how will you define an infinite set? This way you can define also. You can, if you put up the objects into it, then you can't define, but you can just make it as a shape of it. Okay, that way also you can deal with it. Okay, in your book they are given with the numbers, but here it's okay. Fine. And the next property, okay, there are some properties are given. Can you tell me, okay, this will be interesting properties. What will be complement of A and the complement of that?
A.
A itself, correct? Because complement of A is this. And this complement is again going to be A. Am I right? And other one is, now tell me, what is the complement of a null set?
Universal.
Universal set. Why it's universal set? So for example, if A is, if I given A is a null set, okay, A is a null set, then A prime will be what? Will be the same. That will be your 1, 2, 3, 4, 5, 6, 7, 8 and 9, which is nothing but the universal set. Okay. So 5 prime will be equal to is an universal set. There are two properties you have. And the same thing. Can you tell me what is the reverse? What is U prime?
Null set.
Null set. Because U prime is the universal set includes all the objects. If I take a complement of it, there's nothing left over because universal set takes everything. So then it becomes a null set. Okay. So these are the properties of, this is the first operation. First one is a complement of a set. When you say complement of set, what you're going to do is, you are going to find out all the elements of the universal set, which are not the element of A, is called as your complement of a set. Okay. And the next operation, what we are going to do is union of a set. Okay. So union of a set happens for when you have many sets, 2 or more sets. Okay. So let me show what happens is union of a set. Union of a set of sets. Union of sets, not a set. It is more than 2. Okay. What do you mean by union of sets? Is you have, let us say, for example, you have 2 sets. What is that? Let the set be A and B. They belong to some universal set, because if suppose A is a name, alphabets in your name, and B is in alphabets in my name, there will be an universal set, which means all the English alphabets. Okay, so this is so there will be an universal set. So what it says is, union of a set is a set. The symbol is what? A union B is a set where all the which contain all the elements of A as well as B. Okay. So the word is, what does it say? The union of 2 sets A and B is a set of all elements which are in A or in B. They should be A and B. Okay. So for example, let us take, okay, so let A be equal to 1, 2, 3, 4 and B be equal to 5, 6, 7, 1, 5. What 5 we done? 1, 2. Can you tell me what is A union B?
1, 2, 3, 4, 5, 6, 7.
3, 4, 5, 6, 7. Simple. That's what. Shall we see the Venn diagram? So, okay, I want to ask you. So, suppose what will be the union of, suppose if I write B as this one. What is A union B?
Will be the same.
Same. Correct? Fine. So, what we have is, so let me call this as a union of a set. And I'm going to represent a set A. Okay. So, this is your set A. And I'm going to represent another set, that is set B. The elements can be overlapping. Am I right? For example, this one. 1, 2. So that means what? I will make an intersecting set. This is my set B. Now, can you tell me what is the union of a set?
The union of AB, both.
Both. Shading the both. Okay. So this is what we call as a union of a set. Okay. So now, okay, this is for, there's a, okay. There's something called I missed it. We didn't tell. There's something called a disjoint sets. Okay, the disjoint set is this. Why? None of the elements will be common. So if you want to represent a disjoint set in a Venn diagram, what will you do? How will I draw?
Two separate circles.
Separate circles. That's it. A is 1 and B is 1. So here union will be what? Tell me.
A and B both should.
A and B, if they are disjoint sets. Okay? So this is the way we can define the union. This is one property, that is the operation union of a sets. Okay? So now let us try to do some properties of the union of the set. Okay, which you can prove it very simply from here or from the Venn diagram you can prove. Okay, so what are the properties? Let us see. So can you tell me what will A union B be equal to B union A?
Yes.
Of course, that will be the number of sequence. So that is simple. And now, so this is what? What is the property called as? Commutative.
Okay.
Don't you remember? Everywhere we do this, all this. In matrices also we were doing and everywhere doing. This property is called as commutative. A into B is equal to B into A. That's a commutative property. Okay, and then what you have is associative property. Remember? Yeah, associative property. So what is A union B union C? Will it be equal to A union B union C? Will this be equal? Shall we try?
Yes.
Why? Well, let us try. So now what happens? So we are going to say, so we have modified our sets. Now we are going to have 3 sets. Am I right? So we have to represent 3 sets, A, B, C. So let this be our union set. And I am going to have A, I am going to have B, and I am going to have C. Right? So let us first do one by one. Let us take the LHS. First bracket what you have to do? B union C. Am I right? So B union C is what? This. Okay? And then this shaded portion, union, A union this. That means what? This will come. Am I right? This whole portion. A means whole portion means up to here. Everything includes. Okay, so let us take the converse of this side. So what we are going to do now? Second, the RHS, let us prove. What is RHS? A, B, C. What is A union B? A, B, correct. So this will be A union. Will this portion come?
No.
This portion will be there?
No, that portion will be there.
Will be there?
Yes.
Sure?
Yes, because it
Okay, yeah.
included in it.
Correct? And that union C will be what?
Including C.
Include C also. So that's what? So you can put it in a number also, you can prove it. We take out a normal in a roster form, right? And you take any sets, you can prove it also. Okay. So this is what we call in the so union of sets satisfy your associative property also. Okay. The next one is what? Okay, identity. Yeah, identity. That is interesting. Identity is what? Can you tell me what is A union of a null set or empty set?
It'll be
Will be A, correct. Am I right? It's simple to prove. You can draw the Venn diagram, you can see A union of a null set will be always A only. And now then one is the idempotent law. What idempotent law is what? Can you tell me?
universal set.
A.
Okay, same.
That will be correct. It will come there also. A union of A will be what? A. Okay. And the next one is, this will be good. Can you tell me what is A union of A prime? A prime is a complement. Universal set. That's it. Okay. Okay. And next property is if A is a subset of B. Okay. So now can you tell me then what will be A union B?
Will be B, right?
Will be B. How will you show it in a Venn diagram? This is a U. Correct? universal set. You have A. How will you represent? Oh, sorry, you have B.
B.
Ah. You should be B. Am I right? So how A will be?
Inside B.
Inside B. It will be something like this. A. That's only subset. Right? So A union B will be equal to B itself. Fine. And then that's also, this is simple. What you said. A union universal set.
Universal set.
Universal set. This is U. Okay, not union. Okay, universal set. And then, okay, this is good. Okay, this is also easy. Okay, we have done this. Yeah, so for example, let us not take the subset. Oops, U, A, and B. Okay. So we have, we have saw the set A union B. Am I right? That is, takes everything. Will A be a subset of A union B?
Yes.
Correct? Will B be a subset of A union B? Correct. That's it. Okay. So these are the properties of the union of sets. Okay. And the next one comes is the intersection of sets. So exactly third property is the intersection of sets is. Can you tell me what it will be? Intersection. The name itself tells.
Same component.
Correct. Common elements. Okay. Which are the elements of A, which are also the elements of B. This union of a, okay, what is the intersection of a set? Intersection of two sets. Intersection of two sets A and B is a set whose elements are the elements of A and the elements of B. Okay, it means it has to be. So here, can you tell me what will be the intersection?
The center.
The center portion. Very good. So this is what your intersection. Okay, what is the symbol? Symbol for intersection is A, invert the union, intersection B. Okay, so this is what we call as intersection. So you can take the book, they given some example. I can tell you. Okay, that's something we can write here in the set builder form. Union of set is what? A union B is X such that X is an element of A or X is an element of B. Am I right? So here what it will be? Tell me. A intersection B will be X such that X is an element of A and in the place of OR it becomes and X is an element of B. Okay, so this is what your intersection of sets. In the book they given an example. I'll just do the same thing. So A is equal to what? 13579 and B is equal to 1, 2, 3, 4, 5, 6, 7, 8. Can you tell me what is A intersection B?
1, 3, 5, 7.
Okay, so this is what we call as a intersection of a set. So now let us go for the properties of intersection of a set. Okay, so will it satisfy the commutative property? Will your yes, correct. A intersection of B will be equal to B intersection of A. Of course, commutative property is satisfied. Okay, will it satisfy the associative property?
Yes.
So let us take the associative property. For associative property, we need three sets. Am I right? So what is that? A intersection B intersection C will be equal to A intersection B intersection C. Okay. So remember earlier this it should be A B C only. Don't write here B C A or something. When you write associative property, the same form. Which one you are going to perform first? That's the associative property. So shall we see what is associative property here? So let me remove this one. Okay, so we are going to have another set B. Okay, can you tell me what is B intersection C? Oh, this is C. B intersection C is what? This portion. Am I right? And now A intersection B intersection C. A intersection B intersection C. Basically, so we got it. So once we got it, we can, when you want to see it out, you can look it like this. So this is the B intersection C.
Top and left ones.
So this is the B intersection C. Am I right? Now what will be this one?
Okay, center.
Correct. Where is the top? So this is what? This is B intersection C. Am I right? So that is what? This portion. So your B intersection C is nothing but this portion. Okay. So you shouldn't remove it in the in your notes and all. You should give a circle. You should understand what it is. Okay. So this is B and this is C. Okay. So what we have, so A intersection of B intersection C is nothing but this portion. So now let us take the RHS part. So what will be the RHS part? Tell me.
A intersection of B.
First one is A intersection of B. What is that? That will be this portion. Am I right? A, the common between A and B, that is this portion. Can you tell me what is that? So this is what? This is your, this portion is your A intersection B. Now we have to tell A intersection B intersection C. Only the central part. That's it. That's what we are going to do. Okay, so A intersection B intersection C is equal to, this is the exam they may ask, prove this property using Venn diagram. Okay, in that case what happened? You should do it one by one. First you should not let A, B, C. The next, see how do you, in an exam how do you should do is, you shouldn't, because here I am erasing and I am drawing. First you should write like this, A, B, C. First then you write, take the LHS part. Okay, LHS is what? A intersection B intersection C. Am I right? I was telling union, am I right? No, it is intersection. Okay. So first you have to do it. So first let us take for B intersection C. How do we write? So shade it. This is A, B and C. So B intersection C is what? You shade this portion. And then you should write A intersection B intersection C. B intersection C. Okay. So then you do this one. A, B, C. So what this will be? This will be this portion only. Similarly, then you go for the second one, RHS. Okay, you have to go like that. That's why you have to do it in the exams. If they give you some set and if they ask you to prove, then it is simple. You can just use a set symbol, normal set builder form, or even in a or in a roster or a set builder form. Okay, so this property also we saw associative, and then let us go for the identity. What is that? Can you tell me? Yeah, that is a good one. What will be your A intersection null set?
There won't be anything.
What is that?
0.
What is that?
Null set.
Null set. That is a null set. Correct. There won't be anything common, right? Because now what I am giving only one set. A. Okay, I am asking you, what is A intersection of null set? Null set will be null set only. Okay. And now can you tell me what is A intersection of A?
A.
Correct. Equal to A. So remember, A union of A is also A. A intersection of A is also A. Okay. And next comes is interesting. Can you tell me what is A? This is where your book is wrong, written wrong. A intersection of complement of A.
It'll be null set, right?
Correct. There won't be this is A. Complement is outside. There won't be any intersection. So this will be a null set. Okay. This is simple only. There's nothing to be. Okay. If A is a subset of B, okay, it's not C, subset. Okay. If A is a subset of B, can you tell me then what is A intersection B?
E.
A. Correct? Subset of, so subset will be the one. Okay. A. So, okay. And the next one is, what will be your union set intersection of A? A, correct. Am I right? Because union intersection of A is only A only. In the Venn diagram, it will be very easy to
Not
understand.
union set, universal set.
Oh, sorry. Universal intersection of A. Okay, it will be A only. Yeah, correct. So, the next one is this identity intersection. Yeah. Tell me whether this is right. A intersection of B, will it be a subset of A?
Yes.
Correct. Yeah, because A intersection of B is this. Of course, a subset of A. And it's also a subset of B also. So, A intersection of B is also a subset of B. Okay? And then, yeah, then that is a very interesting property, distributivity property. Okay? So, which combines, when you combine the union and intersection, how this is going to, the formula, how this operation is going to see. So, let us see that. What we have is A intersection B union C, right? Yes. So, what this will be? A intersection B union of A intersection C. Can we prove it? How will you prove? You want to prove it in a Venn diagram or the set builder? Venn diagram. Venn diagram is easier. You should sometimes you can prove it in the set builder also. Okay, Venn diagram, let us prove it. So, how we are going to prove it? So, let me first do the LHS. Okay. So, what am I going to do? Let me do the LHS. So, first we have to do it B union C. Am I right? So, B union C is what? Tell me. A, B and C. Okay. So, B union C is what? This. Am I right? And then we are going to say A intersection B union C. So, tell me what this will be. This is A, B, and this is C. So, now you tell me. So, we are.
The center will be one part. That above that, left side of that.
Correct? That's it. Nothing else will be there because this is the only intersection portion, right? So, intersection portion will be, so this will be your answer. Okay? So RHS, LHS is this. So, now let us go for the RHS. RHS, first let us do A union B. Okay, so what we are going to do, A union B, let us write. A union B. Okay, so this is A, this is B, and this is C.
A, not A union, A intersection.
Oh, sorry, A intersection B, correct, sorry. A intersection B. Can you tell me what is A intersection B?
The center between A and B.
Correct, so this is the portion. Okay, and now let us go to the next one. What is that? A intersection C. Okay, so let us do that. A, B, C. Can you tell me what is A intersection C?
Center between A and C.
Yes. Now is very straightforward.
Union
Correct.
will be both.
Union will be the both. Okay, so A intersection B, union A intersection C. That's what you have to prove. Correct? So what this will be? A, B, C. Correct? So A intersection B is this portion, right? So this portion will be there. And A intersection C, that is this portion. This portion also will be there and hence proved. Got it? Clear? Fine. And that's a property. Yeah. And then this will be an interesting one. Okay. That is a De Morgan's law. So what you're going to see next is a De Morgan's law. Okay. You can prove it with the same. De Morgan also can prove it from, from the Venn diagram also. You can prove it simple. A union B, what it says is A union B, and the A union B is a set. The complement of A union B will be equal to complement of A intersection complement of B. Is it correct? Can you prove? How you want to put a Venn diagram? Or we will put a number, some set. Let us take some set. Okay. So let me say, let us take the Venn diagram also. You can prove it easily. Okay. So for difference, let me go for a. So let our universal set be x such that x is an element of natural number and x is less than 10. Okay. And let A be equal to 1, 3, okay. 1, 3, 5. Okay, let us write 1, 3, 5. And B is equal to 2, 3, 1, 8, 7. Okay, so let us prove. What is A union B? Tell me. So now we are going to prove this. So A union B is what? Tell me. 1, 2, 3, 4 is not there, 5, 7 and 8. Okay. A union B whole prime. Well, sorry, this prime, complement of that. So A union B complement will be what? 4, 6, 9. That's it. Correct? So this is what. So now let us go for the right hand side. Can you tell me what is A complement? 2,
4, 6, 7, 8, 9.
Can you tell me what is B complement of B?
4.
1 is there, na? Oh, 1 is there already. Okay. 4, 5, 6, 9. Can you tell me what is A complement intersection of B complement?
4, 6, 9.
Correct? Sure?
4, 6, 9.
Okay? So it is coming. So you can, it is not necessarily you have to prove only in the Venn diagram also. You can prove it in Venn diagram also. If you want to prove it in Venn diagram, you can prove it in Venn diagram. Because the exam they may ask, prove it using a Venn diagram. Prove using some set builder form. Okay. So usually Venn diagram there. Venn diagram also is very easy. So Venn diagram is what? So A, this is what you want to prove, right? So basically what you have, I am proving in a single step. Okay. So this is our universal set. This is A and this is B. Let us write it. Okay. So first one is that A union B. A union B is what? Whole. This portion. Okay. So complement of A union B is what? Everything outside. Correct. So that will be what? So this is what you are. So this is, I will write it in red. What I have written in red is A union B. And the outside, So this is what the complement of okay. So what is this? So this portion is A union B complement of it. Okay. So now let us go for the next one. What's the next one? This is universal set A and B. Complement of A. What is the complement of A? Everything outside. Everything outside A is the complement of A. Then complement of B. What is that? Everything outside B. Am I right? This is what your complement of B. Now, so the union of these complements, the common portion, right? So this portion is not common. This is also not common. Only outside is common. Correct? So what do you have? You will get it, these portions, which is same as your okay. So I said in exam you have to do separate figure, not in a single figure like this. What I'm doing. Okay. So this is the what you call the De Morgan's law. Okay, and in fact the reverse also true. In De Morgan's law. What do you mean by reverse? Can you tell me? A intersection B and its complement will be A complement union B complement. You want to prove it? You want to prove it a Venn diagram? Set builder form. Okay, let us do the same way. Okay, what we had earlier? U is equal to what? X. X is element of n and x is less than 10. And what we had, let us take A is equal to what we had? 1, 3, 5, 5. Okay, that's it, right? And B is equal to what? 2, 3, 1, 5. Enough. Let us keep it. Okay, so tell me. Let us this one. A intersection B. Can you tell me what is A intersection B? Oh, this is a subset. We made it a subset. So let us add up one more term so that at least we make it. Okay. I can have even one more. Why I will stop here? 7 and 8. So I won't make it as an equivalent set. Means the numbers are the cardinality is not same for both of them. Okay. A intersection B is what? Tell me. 1, 3, 5. And can you tell me what is A intersection B? Complement of A intersection B. 2, 4, 6, 7, 8, 9. Correct? So let us go for A prime. Complement of A?
2, 4, 6, 9.
Okay. Complement of B?
4, 6, 7, 8, 9.
What is A complement? Union of B complement?
2, 4, 6, 7, 8.
2, 4, 6, 7, 8, 9. Am I right?
No.
Are they both same?
Yes.
So therefore, that's also proved. Okay, so De Morgan's law can be proved. So this is interesting. And now, so what we saw the property, we saw the complement, we saw the union, we saw the intersection. Now next one what you are going to say is the difference of sets. Okay, so difference of sets. Simple. So it's basically what happened if you are say A minus B. The symbol is typically A minus B. Okay. So it's you can if I draw an Venn diagram you can easily see. U, this is A and this is B. Can you tell what is A minus B will be?
A without the
Without that portion of B. That's what your A minus B. Now you write. Now you express it in words. That's what a difference. Okay. So what it says is the difference of set A and set B is a set of elements which are in A but not in B and is denoted by A minus B symbol. Okay. Okay. Yeah. That's interesting. So A minus B, this can be also written as A union B complement. Oops, sorry. No, A intersection. A intersection of B complement. Are they both same?
yes.
Correct, na? See, your A minus B is this. B's complement will be everything outside. And the intersection will be only this portion. Okay, the similar way you can do it also. B minus A will be equal to
B intersection.
A intersect A complement with intersection of B. Am I right? B minus A, yes. Because B minus A will be what? So B minus A will be this portion. This is A. So B minus A is here. Am I right? What is that? A's complement is outside this intersection with the B. Only this portion. So it comes up to be like that. Fine. So yeah. So this portion is what? This is B minus A. On the other hand, this portion will be what? A minus B. Okay? Yeah, and interestingly what happened? When you take a union of A minus B, see A minus B and B minus A is what you call as a disjoint sets. Why? They don't have any element in common, you can see. This and this will not have anything in common. Okay, so when you take a union of two disjoint sets, that's what you call as your symmetric difference, or it's called a symmetric difference of sets A and B. That's what you take, join this both. You got it? Huh? So, okay, some properties of difference in the set is what? Yeah, that's all. This is we can just write it down. That is simple. So, A minus B is subset of A, correct? Correct? And then similarly, B minus A will be B. Okay. Do you know this is subset? Earlier also we wrote, see that is a proper subset. When it's a proper subset, there will have at least one element which is not a element of, see A is a proper subset of, suppose if you write A is a subset of B, so there will be at least, B will have at least one element which is not element of A. Okay, when you say subset, doesn't matter. Equal, we said equal sets are can also subset of each other. Okay, so when a proper set, A and B should not be equal. Okay? Neither equivalent. Correct? So that's the one property. This sets that I said now. Yeah. What they said is the sets. The sets A minus B, A intersection B and B minus A, they are mutually disjoints. Am I right? Is that correct? Where A intersection B is what? That is this portion. They are all three are disjoints. Am I right? So that's what he was mentioning. So, so can you tell me what is the intersection of a disjoint sets?
Union of sets.
Intersection of disjoint sets.
Intersection design will be null set.
Null set. Okay. So from here you can see. So what is A union B? The whole thing. A union B is nothing but
A minus B and
A intersection B and B minus A. So then you can, from here to you can write a property directly. So A union B, which is whole thing, that is this plus this plus this. So what is this? This is A minus B
plus
union A intersection B, correct? Union B minus A. That's it. Got it? So that's the one part, and that's all. Okay. So yeah, now what they call? Okay, this is what I was saying. So if you take only union of A minus B and B minus A, that means only this portions you have. Am I right? So this is, they call it, what I said, symmetric difference. Okay, so the symbol is what? There's a symbol for that. That is A B. So what is this? This will be A minus B union B minus A. Okay, so that is a symbol for symmetric one. Okay, fine. So now let us go for certain properties. Okay. Yeah. Okay. So same way we can do the same way. Can you tell me this one? I can write it here itself. So A symmetric difference of the sets between A and B will be equal to, you can also write it as A union B minus
A intersection B.
Correct? That is simple. A union B minus A intersection of B. Because A union B is the whole thing. A intersection of B is this one. Minus means you just subtract them. So you get the asymmetric difference of A and B. Okay. And then, can you tell me what is the symmetric difference of A with A?
0.
0 is what? Null set. Correct? Yeah. And then what will be the symmetric difference with A with
it will be A.
A only. Correct? Simple, nah? Because this is A, you take only A. Okay, so that's what there. Yeah, this is an interesting property. Can you prove this? If symmetric difference of A and B is equal to symmetric difference of A and C, then it says B is equal to C. Am I right? Is that correct? Okay, because symmetric difference of A and B is what? This is the portion. Okay, and if that is equal to another one, that's only possible when B is equal to C. You got it? Huh? So that's what they write it here. Then, yeah. That's also okay. That's different. They follow the symmetric difference, follow the commutative property also. Correct? A symmetry of B will be equal to B symmetric difference with A of A. Correct? And yes, they form the associative also. A intersection B symmetric of C will be A intersection B and the symmetric of A intersection C. Is that correct? In your book, there is a mistake. There it is B here. Okay. Shall we prove? I'm going to let us prove with the Venn diagram only. That is easier. Okay. So tell me. We are having now 3. Huh? A, B, and C. So let us do the LHS. First, we have to do the B symmetric difference of B and C, right? B and C symmetric difference is what? This portion and this portion, omitting the common area. Correct. That is this portion and this portion. Okay, so this portion. This is what? This is your B C. Okay, and then we are going to A intersection C. Can you tell me what is the intersection between C? These two. Correct. So they are the ears of a kitty. Correct. So these two parts. Correct. So this is what? So this portion is what? Your A intersection symmetric difference of B and C. So this is your LHS. Now let us do the RHS. Okay. So what is RHS? Let us try. A, B, and C. So first one is A intersection B. What it is? This portion. A intersection C. So what this will be? This portion. Okay. And the symmetric difference between these two. Center portion. That's it. So this won't be there. Okay. This won't be there. And what we'll be having is this one here. Am I right? They both are same, hence proved. Got it? So this is the way you can prove all these properties. Okay. So the next one, the last portion we will see. The properties of the cardinality of the set. That's also important. Huh? And some property, I will not prove it. Okay, we don't have to prove this. That you prove it in the higher classes. You can prove by mathematical induction. Let's see. Properties of the cardinality of the sets. Okay. Yeah, this is it. So once see, the beauty of why we are defining this union intersection is what we can do is, see, for example, correct. So now we can see the cardinality of given a set, two sets A and B. Cardinality of A union B will be equal to cardinality of A plus cardinality of B. Is this correct? Sure?
A is adding.
Okay, so let us take an example. A is equal to 1, 2, 3, 4, 5. B is equal to 4, 5, 6, 7, 8, 9, 10, 11. Can you tell me what is N of A?
5.
N of B?
7.
What is A union B? Tell me. A union B, let us write down here. Okay? So A union B.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Tell me. 1, 2, 3, 4, 5. No 6. 7, 8, 9, 10, 11. Can you tell me what is N of A union B?
10. 10.
10. Sure? 10. Are this property is correct?
Correct.
Okay. So, can you tell me what is the intersection of B?
4, 5.
Tell me 4,
5.
5, only 2? You're missing something. Correct. Only 4 and 5 is there. 4, 5. Yeah. N of A intersection B. B how much? Tell me.
2.
2. So, can you say anything from here? Seeing these numbers?
B minus N of B.
N of B?
Minus N of A.
That's, no, that also won't be correct. I can change the number, then it go other ways, right?
Okay.
That's easy, na? When you are think of in a Venn diagram. Okay. So what we are doing? We are having A and we are having B. Okay. So basically, what happened? The number you have to take the total number counting, right? When you take A union B, so you take only these numbers total. Correct? So now what happened? When you are adding this cardinality for individually, so then what happened? For N of A, you add up the whole.
Okay.
And for N of B, you add up this also completely. So this portion you have double counted, na? So you have to subtract that. That is nothing but an intersection. Got it? That's what, simple. That's what is Venn diagram. When you look in the Venn diagram, it's these things easy to understand. Okay? Okay. Now let me ask a question. Is there, under any condition, can this be this?
Both of A and B should be equal.
Should be equal. And equal will become double. 2 times you are dead. Tell me.
B will be a null. No, it's a.
No, I don't bring null set.
Okay.
Now what it will be?
Okay. A will be. Okay. We're removing the intersection.
Correct? Yeah. So what is the intersection of A and B? So what we did, what I said, I told you minus N of A intersection B. I asked you, is there any way can I remove it?
You can make it 0.
That means you have to make it 0. That means two sets just be disjoined. When they are disjoined, there is no intersection. Am I right? So that's what. So when A and B are disjoint sets, then N of A union cardinality of A union B is equal to cardinality of A plus cardinality of B. And in that case, can you tell me what is the cardinality of A intersection B? For disjoint sets.
But then there won't be, for disjoint sets, A intersection of B will be zero, null set, right?
Correct. That's why I'm asking what is the cardinality of it?
0.
What is the cardinality of null set? It's 0, na? That's why I'm asking. Okay. Because your A intersection B is what? For disjoint sets, A intersection B is nothing but a null set. The cardinality of null set is 0. That we saw yesterday itself, na? Okay. So now let me go for the next property. Yeah, this is also. These all properties can be proved. Okay. It's simple. You can think it over also. You can prove. Okay. So N of A intersection B complement of B plus N of A intersection B should be equal to N of A. Is that correct? So now we are not going to speak about disjoint sets. We are saying normal sets. A union of B complement is what?
A
sorry, A intersection of B complement. So this is your U. Okay, B complement is what? Everything excluding
B.
B. And that intersection with A will be
A,
this
but
portion.
without the,
Correct? And now plus N of A intersection B.
there will be enough A.
Correct? It's N of A. You got it? You're not going double counting. You just want single counting only. Correct? So that's why you can prove it simple. These are all. And then is N of A complement intersection B plus N of the same thing. This is A intersection B will be equal to N of B. That's the same, exactly opposite. Okay, you can do it out. Same, exactly opposite. Okay, that's one property. And then actually there are some the typos in your book, so this can be. I'm not sure which other things have a typo. Okay, so then we are having N of. This N of means cardinality. Always remember. A intersection complement of B plus N of A intersection B plus N of A complement intersection of B will be what? Tell me. Let us try to see. They are having A and B. First one is what? A intersection of B complement. That is
A, but without the intersection.
this portion. Am I right? That is this portion. Then A intersection B. That is what? Which portion?
A, center part.
Yes. So that is this portion. Okay. And then A complement. That is outside. Intersection of B. So which will be?
B part, but without the center.
This portion. Am I right?
That is A union of B.
That is A union of B. Okay. So this will be what? Tell me. This will be N of A union of B. Okay. 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 So then let us go for now 3 sets. With the 3 sets we are having. For any sets A, B, C. Okay. So let us write down that property also. You should, in a way, you have to mug up the formulas for all these properties. Okay. So sometimes you may, for the problems, if you use it, I don't know what are the problems they given. I have not gone through your book full. Solving some problems, you may have to use these properties. Okay, so now what they given is, okay, let us write A, B, C. A, B, and C. Okay, what they have written is, yeah, okay, this way they have written is, let us prove this. N of A union B union C will be N of, yeah, that's the same thing, this simple, plus N of B plus N of C minus N of A intersection B. The double count, na, you remember we said that, minus N of B intersection C minus N of A intersection C plus, then plus N of A intersection B intersection C. Center part has to, because you cancel the second central part fully. Am I right? You can prove it very simple. So A union B union C is nothing but the whole sphere. Okay, so this will be. So when N of A, that means N of A is taken here, N of B and N of C. So how many times, which are the portions we have counted twice?
Intersections of A and B.
Yeah, Yeah, these three portions gets counted twice. Correct. So n of A plus n of B plus n of C. So n of C will have these two will be counted twice. This one. So then minus A intersection B. A intersection B will remove this one count. Correct. Should you want to? You understood clear? Okay. So see the point. What? Let me put it. N of A, N of B, N of C. So what? N of A is what? This whole thing. N of B is what? This whole thing. So this portion. I will mark it when now in red. Whichever the portion is double counted. Okay. So this is double counted. Correct. So this portion is doubled. And then plus N of C. So that means this portion is also double count. Why the color got changed? I don't know. Okay. Whereas this is 3 times counted. Correct? Because this one. So this portion is counted for thrice. So let me write it out. So what we are having, this we are having it 2 times, 2 times, 2 times. And then this is one thing we have counted for 3 times. So now we have to subtract all those portions. The first one is what? A intersection B. This we have subtracted. So this became 1. Then this is 3 times. Okay. So now this became, when I subtract this one, this has gone completely. Okay. And this becomes 2 now. Correct. And then I am subtracting B union C. Sorry, B intersection C. That is this. So I have subtracted this portion also. Am I right? So now this became 1. So this portion is only 1 now. But this is 2. Now I have subtract this portion also. So N of A intersection C. So that is this portion I have counted. And along with it, I have missed this portion also. Correct? Because I subtracted that portion also. So now I have to add up this portion. So this portion is nothing but A intersection B intersection C. So that's how we are getting this property. Clear? Yeah. Okay. This property I am not going to prove it. Okay. You remember yesterday we said something about a power set. Suppose we have a set A. And the cardinality of the set A, if this is, let us call it as M, then the cardinality of its power set, N of P of A. You know what's a power set? All possible subsets. You have a set A, all possible subsets. You remember we said we did that. Suppose you have A is equal to 1, 2. So then the power set will be what?
1, 2, 1 and 2 and null set.
Yeah. First one is null set. 1, 2, 1 and 2. So what is the cardinality of this one? Tell me. This is what? N of A equal to how much? 2.
That is 2.
N of P of A is
4.
4. Is that correct? Okay, because 2 to the power of 4. You do it for 3, you will get the same thing. Okay, so this is what 1. And the last property is what? Yes, that is the similarity difference. Yeah. N of similarity difference between A and B will be equal to N of A plus N of B minus 2 times N of A intersection B. Is it right? Okay, let us see. So what we are going to do, so we are having this, let us have this Venn diagram of A, this is universal set A, this is B. So similarity, Similarity difference of A intersection B is what?
A within B, but without the.
Without the common portion, right? These are the ones we have. Okay? Now you say, so n of A. N of A is this whole portion. N of B is this whole portion. So this portion is counted double. Okay, so what is this portion? This is nothing but the intersection, correct? So you subtract it twice. That goes off. That's what we have done. Okay, clear? Yeah, that's all the properties with this all the operations with the set we have. And next class we will see about the intervals. Okay.